Anova. So the question given here is company A, B, C data is provided, and are the profits between the companies different or not, that we need to check. So the null hypothesis is all the mu's are equal, and alternative hypothesis is at least one company has different profit than others. So if you observe this, you have got this f value calculation. So if you remember in class we have discussed related to this sum of square is sum of the columns that are provided here, C31 to E31, and here within the column is C28 to E28. We have done it like that. So this one, this which we have calculated here, right? So we have done it this way. Now when we divide SS by DF, we get MS, and when we divide this MS divided by within the columns, we get this 6.34, and then from there we calculate this p value and f critical. So now if you remember, we did this in mock. So we have to choose one way Anova in the Jamovi. Now how we will select Anova? We'll go to Jamovi and we go to this Anova and we select this one way Anova, and we will put the variables here. So dependent variable is cost, because the question is related to the amount, and the grouping variable is the startup. And now let us observe the analysis part. So when we check the normality and homogeneity, we see here that the normality test that says that p value is greater than 0.05. So data is normally distributed, and we say that we also see that p value is greater than 0.05 for Levin's test. So variances in profits are same in all the companies. So since profits are normally distributed and variance in profits are equal, homogeneous, we select Anova assuming equal variances, so which is Fisher's. So this we discussed in class. And then descriptive table and exclude cases, analysis by analysis. Now since variances are homogeneous as indicated by Levin's test, which is p value is greater than 0.05, we select Tuckey's test for post hoc. We perform post hoc to find out which company has significantly different profit than others. So I hope this helps you to recall what we did in the class. Now when we do this, so we get this output also, and we find out that the n value is same, the sample size is same. So this is a balanced data. What do we call this? This is a balanced data where numbers are equal. So when the numbers are not equal, we say it is unbalanced data. Now if you see, this is the degree of freedom. So 3 minus 1 is 2, and this is 60 error degrees of freedom. So 61 minus 1. So this is your data related to the data given here. Now if you see the p value in this particular demo, so p value is less than 0.05, so we reject our null hypothesis, right? So this mean difference also you have to click in statistics, and Tuckey's test you have to check. Now what does it tell? you see a 0.15 is p value in case of A. In case of B, you see it is 0.002, which is less than 0.05. So it means that company B has significantly different average profit than company C. The positive mean difference indicates that company B has higher mean profit than company C. So this is something related to the values of the comparison of the two companies. So this is about the one-way demo. Now we go to this one-way practice. Now in the one-way practice, if you observe, the data is given related to the business startup cost. So pizza startup cost, for baker startup cost, for shoe stores, for gift shops, for pet stores. So now you can see that the numbers are different. So this is unbalanced ANOVA design. So the question is, do startup costs differ between shops? So now let us see. We'll go for the normality and homogeneity. So what do we find in normality and homogeneity? That p value is greater than 0.05, and homogeneity also says that p value is greater than 0.05. So Levin's test says the variances are same and data is normal. Now when we are doing this, we get assume equal and we check the Fisher's test, and we see that p value is less than 0.05. So data is hypothesis is rejected, and you can see the number here which is showing it is not equal. The sample sizes are not equal. So this we can observe from the data itself. And you will take mean difference and report significance. And Tuckey's test. Now Tuckey's test will tell you about the difference between the samples, and we can calculate it easily from here. So Baker's data, so you can see here 0.09, and this is 0.02, and this is 0.5, this is 0.076. So if you see the Baker's data, this data is less than 0.05. So that's the reason there is a difference between average startup cost of Baker which is higher than the pet store, and Baker startup cost is different than pet store. So this is what is the output, right? And this is F value. Now let us move to the one-way post hoc. So now again, if you see, the numbers are different here. So average returns differ between sectors. A simple question is asked: does the average return differs between the different sectors? So this was given for Excel. Now if we do it in Jamovie, so you have to select the one-way ANOVA non-parametric. Why do we select? Because when we check the normality, we got p value is less than 0.05. So when you check the normality, we find that p value is less than 0.05. So you need not do anything more than this. I'll just tell you, go to ANOVA. When you find out that p value is less than 0.05 for Shapiro-Wilk, Shapiro-Wilk p value is less than 0.05, then we say that the data is not normal. So when the data is not normal, you have to take this one-way ANOVA, Kruskal-Wallis in non-parametric. So what did we choose? One-way ANOVA, Kruskal-Wallis in non-parametric, and you have to put the variable here and grouping variable here like what you do in normal ANOVA, and you have to click this DSCF pairwise comparison. So what the other analysis was doing here, this particular Levin's test, homogeneity test we did, Fisher's test we did, and between groups analysis was done with Tucky's post hoc. This way, this post hoc test will be done with DSCF, which is Dwarf Steele Critchlow Fligner pairwise comparison. So now let us see. So again I'll repeat how did we proceed. Now when the data when we take this data and we do the normality test, we found that data is not normal. So when the data is not normal, we have to take ANOVA non-parametric, and when we take ANOVA non-parametric, we get the same figure, same kind of data table like how we got earlier. So dependent variable we have to put here, and grouping variable we have to put here, and we have to keep DSCF pairwise comparison. So when you find out this, you got P is 0.003. So the null hypothesis is rejected, and you also got pairwise comparison return. So here again you saw that auto, IT, pharma industry, and the values P values 0.05 and 0.080. Remaining all you can see they are big as compared to others. Here it is 0.06. So if we see, if you remember when you made the research papers, I told you if it is less than 0, if it is not coming for 0.05, we can also once check it for 90% significance. If the question is asked related to 90% of significance, you can do it for 90% significance. If it is asked for 95% significance, we have to check it in 5% level of significance. So we see that here none of the data is significant at 5%. Right. So in case the question was asked for 10% level of significance, so you find out that the auto sector is different than IT and pharma industry, pharmaceutical industry. Also the median returns in BFSI is different than IT. If we look at the so we can see here, right? So if we see the descriptive here, we can find out the details like auto is 0.238, which is higher. Energy we cannot take, but IT and pharma industry, as compared to them, the auto industry has higher return, and it is showing the significant difference in case of the data provided here. So at 10% level this is coming, but when we check it at 5% level, we don't find a proper outcome. Now when we take the two-way replication, so when we take this two-way replication, the data is provided like weekdays are there, media is there, responses are given. So for all the combinations of weekdays and media, we have more than one observation. For all the combinations of weekdays and media, we have equal number of observations. So the question is, do response generate differ between media and days of the week? So on different days of the week, the responses are different or not, we need to check. So all the null hypotheses are same, main effect and interaction. So if you remember, I have told you here, so there are main and interaction effects. So if you observe the cross relations also we need to, so this is an interaction effect you can observe, and these are the main effect. So so when we observe this data, like for example average responses generated by all media on the weekdays, so this is the interaction effect that we observe here. All responses generated by at least one media on a specific weekday is different than the other media. So now let us see. So we will for this two-way ANOVA, because there are different variables given, we have to take this ANOVA. You have to go to analysis and you have to go to ANOVA, and then you have to do the analysis. and you have to make sure that you choose um, responses here and media and weekday in the grouping factor. So when you do this, the components are given media weekday and media weekday interaction here, and type 3 sum of squares, homogeneity, normality, post hoc test, and Tucky's test, right? Now let us go through this. So the data, if we check the normality first, students, you can use 1.25 speed to observe this video, because sometimes I am a bit slow. So based on your requirement, you can increase or decrease the speed. Now the output is not mentioned here, but then let us talk. So since the data is normal, we are using Tucky's test here, and if you observe p values are less than 0.05, so average response generated differ between at least two media, two weekdays as well as two combination. So null hypothesis is rejected. And also if you observe here the mean difference here, and the Tucky's test, so average responses of generated on media is significantly higher than Thursday. uh, so Monday, what was the response, is higher than Thursday. So and this also talks about average response generated on Monday, because p value is less than 0.05, and that's how we observe that Monday whatever is generated is higher than Thursday. Similar way, uh, the average response generated on Monday and Friday is different. Now if you observe here, this data Thursday and Tuesday comparison, so again Tuesday is significantly higher than Thursday, and then if you observe this is in negative, so on Tuesday is significantly lower than Friday. And here again 2.167 is positive and minus 2.75. So this is average response of generated on Wednesday, significantly lower than uh, Friday. So average response generated on Thursday significantly lower than Friday, here minus 4.97. So Friday generates the highest average response, Thursday generates the least average response. Now post hoc comparison, average response generated by news is higher than sports, average response generated by business is higher than sports. Similar way we will be doing for weekday and media. So you will observe 0.05, the data less than 0.05, then you can find out that sports generates less response on Monday than news. Okay, so Now if we take, so this is that figure that we have got. Now if we say two-way without replication, so this is very simple. You can do this in Excel. So you can take this data and you go to data analysis. When you go to data analysis, you have to take two-factor without replication, and you can select this figure and you have to put it like this, and you have to put it labels, and you have to select the output range, and you have to do OK. When you do OK, you get the figure like this particular output. Now what does it says? Two-way without replication. Now why did you choose that? Because we are comparing means of different years as well as different indices, hence it is a two-way design, right? So the question asked here is, average returns are same for all the years, average returns are same between sectors. So sectors and years, two different types of information is required. For each combination of year and index, we have only one return, hence it is without replication. So return is same and combinations are different. So now if you observe Anova, so when we did this calculation here, you got this F value. So if you remember, I have told you how do we calculate it in Excel. This divided by this, we get this, and when we divide this by this, we get the value of F, right? So these things you should remember. Now if you observe this p value, which is less than 0.05, so this tells that average returns differ across years, and this second tells that average returns differ between sectors. Okay, and for this F value, table F critical, I have given you the PPTs earlier long back, so you can check it from that particular data. These things, these kinds of table for Z, F, so this we discussed earlier, right? Now if we see this two-way unbalanced, now if you remember what is unbalanced, when we get the n value as different, right? So you need to do what? You just need to get the data in your Jamovi, and you have got Anova, and the question asked here is average change in BP due to all drug doses are same, average change in BP in all the diseases are same. So the interaction effect is BP and drug disease, so we have to check for that. Now BP, drug dose and disease. Now let us see here, you got the things and you have got all the data, and then you have seen that the numbers are not, n values are different. So that's the reason why it is called unbalanced. Now when you do ANOVA, you get this output, and p value is less than 0.001. Null hypothesis is rejected, so disease and interaction of drug dose and disease is telling that p value is less than 0.05. and p tucky, if you observe blood pressure in, so A versus B, A versus C, B versus C you got. So now if you observe blood pressure in disease A is significantly lower than B, and because this mean difference, and blood pressure in disease A is significantly lower than C, and BP is significantly